Hello, advanced algebra students, and welcome back to another video lesson where we continue on our path of learning about trigonometry and trig functions. SOHCAHTOA! Today, we're going to look at angles of elevation and depression to see if we can't draw a story problem to help us figure out which trig ratios we should be using to solve a particular problem. With that being said, here's a couple of important notes. Angle of elevation versus angle of depression. Imagine that we're standing on a hill, we're looking straight out to the horizon, or what's called the horizontal. Angle of elevation is from that horizontal up to where we're looking at something, planes, birds, treetops, right? So it's this inside angle. Angle of depression would be looking down at something. So from the horizontal down to where that dog or an animal or a tree or whatever might be sitting. So that angle is on the inside. The key here is that these will always be in relation to this horizontal, right? And that throws a small tiny loop in especially this angle of depression, okay? Typically, if I'm standing up on top of a building looking down at a house, I say that I'm looking down at a 12-degree angle of depression, which is true, right? I'm looking down here, but 78 degrees is not the angle of depression here. This 12 has to be in relation to that horizontal. And one of the things we learned in geometry was that if this horizontal line is parallel to the ground, this 12 is congruent to this 12. And so 12 would be this measurement down here in the bottom right-hand corner. Now, it's true that, yes, this does equal 78. However, you're going to be asked to find the angle of depression. When you're doing that, you're asked to find this particular angle right up here, not the 78. So we have to relate that in this picture, this bottom right one is the same as this one outside the triangle. We've got a specific example that will help us look at that. Let's take a look at example number 1 about fire trucks. All right, a 115-foot ladder is attached to a fire truck, and it rests against the side of a building so that the top of the ladder is 111 feet above the ground. Find the angle of elevation formed by the truck and the ladder to the nearest tenth of a degree. Tenth of a degree. All right, so here's my building. All right, maybe we'll show that we got a couple windows in here. All right, and then we've got, the bottom of the building, I can draw it, is sitting here, which means we've got a fire truck also sitting on the ground. Oh boy, this is going to be challenging. Okay, that's a wonderful fire truck. Hopefully you see what's happening here. Anyway, we've got this ladder coming out of the back of the truck that's going up to the building, right? Another wonderful ladder. The ladder itself is 115 feet above the ground. It's also reaching 111 feet onto the building. So from here back down to the ground is 111 feet. So let's just assume for this picture that this 115 includes this distance from the base of the truck all the way up to the top of the ladder. Okay, here is our right angle. The angle of elevation, we're trying to find the angle of elevation formed by the truck and the ladder. So if I'm sitting in the truck looking out to the horizon, that's this way, they're asking me to find what's this angle of elevation from the ground to where that ladder sits. So we're going to mark this as our theta. Okay, we are looking for this angle measurement right down here. If I'm looking for this angle measurement and I'm standing here, I've got to figure out what two parts of the triangle do I have so that I can then use the correct trig function. All right, well, this is the adjacent side over here because it's right next to the angle. This is the hypotenuse because it's opposite the right angle where those building and the ground meets, and this then has to be the opposite. So which of our trig functions uses O and H? Well, that would be our sine. So sine of theta equals the opposite side of the building, which is 111, over the hypotenuse of the triangle, which is 115. What we learned yesterday was that to solve for an angle measure, to get rid of sine, we take the sine inverse of both sides. So theta equals the sine inverse, again called inverse, of 111 over 115. Now, before I go to Desmos, I'm just going to read one more time that it's asking us to find it to the nearest tenth, or 1 decimal place. And so sine inverse, once I can get it to low, there we go, sine inverse of 111 over 115, 74.8 degrees. So that angle of elevation, that angle of theta, is 74.8 degrees. Meaning the angle of elevation from where we stand on the truck, looking up to where this ladder reaches on the building, that angle of elevation is 74.8 degrees. Let's try our second and final example. A hawk is cruising at an altitude of 215 feet, meaning, guys, so here's this hawk right up here. Here's the bird. It's above the ground 215 feet above the ground. It spots a prey at a slant distance of 406 feet. So that's what this is representing, this slant distance of 406. Okay, looking back at its prey. And maybe the hawk is flying this way. We want to find the nearest hundredth of a degree, the angle of depression. The angle of depression. So this is where we have to be careful, right? The hawk is flying this way, meaning its horizontal is this line right out here. The angle of depression is this particular angle right in here. Now, that's outside of this triangle that we've created, right? The hawk is 213 feet above the ground. So that's this side. The slant height is 406. Therefore, we can create this triangle right here. Okay, so we're looking for this angle of depression. How far down must the bird look? But remember, this angle, because of parallel lines, is also the same as this angle. So that is the one I'm going to label as theta. Okay, now if that's theta, we're going to label the sides again. 406 is opposite, so that's our opposite the right angle. That's our hypotenuse. Right next to the angle, that side is the adjacent, meaning this has to be the opposite. So what trig function uses opposite and hypotenuse? Once again, the sine of our particular angle. So the sine of theta equals the opposite, which was 213, over the hypotenuse, which is 406. And to solve for our angle measure, we take this sine inverse of both sides so that we can calculate the sine inverse of 213 over 406. So I'm going to go back to Desmos and punch in 213 over 406. 213 over 406, and we get to the nearest hundredth now, 31.64. So theta, or the angle of depression, would be 31.64 degrees. That hawk is looking down 31.64 degrees at its prey. So just be careful with the angle of depression and where it's located in that certain triangle. If you have any questions as you're going through these, please make sure that you reach out. Otherwise, until next time, everyone, stay safe.